Tunnels, written by Jill Sherman. Focus question: how and why are tunnels created? Yeah, going places. For much of history, when travelers came across obstacles like mountains, they had a decision to make. Should they go around or over? Both options were difficult until someone decided to go through. Today, tunnels allow safe and speedy passage through hills and mountains. They also allow people and goods to pass under cities, rivers, and seas. The largest tunnels are amazing examples of the work modern engineers can do. The histories of tunnels. People have been building tunnels for thousands of years. However, for much of that time, tunnel was dangerous and could take many years of hard work. In the 1860s, tunnels building became much easier when Alfred Nobel came a dynamite easy to use and safer than other explosives at the time. Dynamite allowed people to blast through rock in a moment. Since then, the technology has continued to advance. The tunnels have grown larger and more amazing. Building tunnels. Today, workers have carved tunnels through rock, mountains, under large bodies of water, and below busy cities. Before building a tunnel, engineers look at soil and rock samples. They drill test holes to discover the type of rock they will need to dig through. Once they have this information, they can design a tunnel that will not collapse. Tunnel usually follows three basic steps: dig, support, and line. First, workers dig part of the tunnel. They may use tools, machines, or explosives. One part of the tunnel has been cleared. It is time to step 2. Support. Any unstable ground must be made stronger to prevent a collapse. How they do this depends on the material and the tunnel has to go through. Once the tunnel has been made stable, workers building lining or inside the tunnel using 3 basic steps. People have built amazing tunnels all over the world. Tunnels through rock. The Shakan tunnels connect Honshu, the main island of Japan, with Hokkaido. It's 54 kilometers, 34 miles long, making it the second longest tunnel in the world. To build the tunnel, workers had to blast through tons of hard rock. To blast through rock, workers first drill small holes. The type of rock determines how deep and how far the holes need to be. Then workers pack the hole tightly with explosives. After they set off the explosive, workers cart away the pieces of rock created by the blast, called muck. Turnings of soil often don't need extra support because they are already sturdy. However, areas with broken rocks still need to be secured. Workers may install long bolts or spray the area with concrete. They need to make sure that the rocks won't move as they continue to work on the tunnel. For some tunnels full rock, workers use huge tunnel boring machines. At the front of the machine is a blade in the shape of the circle that contains disc cutters. The blade rotates the carving and grinding onto the rock. The mark is scooped into a belt that moves back toward the tunnel edges. While these machines make building tunnels easier and faster, they cost millions of dollars. If they break down, they can sometimes take months or even years to repair. Tunnels through soft earth. Building tunnels through soft ground, such as sand or gravel, can be dangerous. The happening worker push a steel cylinder called a shield into the earth for support. They then dig the material within the shield. Next, they install a liner, which often made of steel or concrete, with that completely. They push the shield deeper ahead and repeat the process. Mark Bruno invented in the method in order to build the Thames Tunnel in the 1840s. Tunnels underwater. Building tunnels under bodies of water present additional challenges in many building sections of the tunnel above ground. When the change is complete, the sections of tunnels are sunk and connected together. When everything is sealed, the water is pumped out of the tunnel. The Marmara Tunnel, which connects the European and Asian sides of Istanbul, Turkey, was built using the change method. The Channel Tunnel, which crosses under the English Channel between England and France, was built using another method. 11 tunnel boring the machines began work on the other side of the tunnel. They met in the middle 2 years later, and the tunnel was finally opened 4 years after, in 1994. Conclusion: these amazing tunnels have millions of people and tons of goods move each day all around the globe. As we will continue to create newer, faster, and better modes of transportation, they still come across the same obstacles. To get people where they will go faster, new tunnels will need to be built. Fortunately, the technology allows for the construction of longer, deeper, and wider structures more easily and safely than ever before. Who knows what amazing tunnel will be built next?
Good job!